Hi friend, welcome to Math A to Z. Today's class in higher level competitive mathematics. So the question of this class are all of M.C.Q type. Now go to the subject. First question of the class is, which of the following is or are correct? Option A, limit n tends to infinity 1 by 1 into 2 into 3 dot dot to n whole to the power 1 by n equal to 0. Option B, same does not exist. Option C, limit n tends to infinity 1 by n into 2 plus 3 by 2 whole square plus 4 by 3 whole cube plus 2 dot dot n plus 1 by n whole to the power n equal to e. And the last option is the same as C, but it is given that does not exist. The first option is limit n tends to infinity 1 by 1, 2, 3 to n whole to the power 1 by n equal to 0. If we let x1 equal to 1 by n, then clearly this is tends to 0. So by Cauchy's first limit theorem, we get limit n tends to infinity x1, x2 to xn whole to the power 1 by n equal to L. If this is xn. If xn tends to L as n tends to infinity, so Cauchy's first limit theorem states that this is also L. Now if xn equal to 1 by n, then obviously x1, x2 to xn is equal to 1 by 1, 1 by 2 to 1 by n whole to the power 1 by n tends to 0. So the first option A is correct. And the second option B, second option, this is same, but it is given that it is does not exist, so it is wrong. Now the third option is limit n tends to infinity 1 by n into 2 plus 3 by 2 to whole to the power 2 plus 4 by 3 whole to the power 3 plus n plus 1 by n whole to the power n equal to e. Here xn, if we choose xn equal to n plus 1 by n whole to the power n, that is 1 plus 1 by n whole to the power n, and we know this tends to e as n tends to infinity, right? So also if we use Cauchy's first limit theorem, we get limit n tends to infinity x1 plus x2 to xn by n tends to or equal to L if this limit xn, if limit n tends to infinity xn equal to L. But here this is E, and x1 limit n tends to infinity 1 by n, x1 means 1 plus 1, that is 2 to the power 1, that is 2, plus x2 means 1 plus half, that is 3 by 2 to the power 2 to last n plus 1 by n to the power n equal to p. So the option C is also correct. And in the last option, this is does not exist. Is given that this is does not exist. So it is must be wrong. So here option A and option C both are correct. Sequence an equal to sin n pi by 2 plus minus 1 whole to the power n by n. N belongs to capital N, set of natural number, has lower limit n equal to minus 1, option B upper limit n equal to 1, option C lower limit n equal to 1, and the last option, option D, upper limit n equal to 2. N equal to sin n pi by 2 plus minus 1 to the power n by n. And we know that sin n pi by 2, this sequence have three subsequence. One is sin 4k plus 1, 4k minus 1 pi by 2. Secondly, sin 4k pi by 2, and last sin 4k plus 1 into pi by 2. And obviously this is equal to 0, that is sin 2k pi equal to 0, and this is 2k pi minus pi by 2, that is 2k pi minus pi by 2 means this and in this quadrant. So this is minus 1 and this is plus 1. So its three subsequence. One converts to minus 1, another converts to 0, and the last converts to plus 1. And this sequence is tends to 0. Second sequence is tends to 0. So the sequence A has three subsequence. One converts to minus 1, another converts to 0, and the last converts to 1. So it has three subsequential limit. So in the first option, lower limit an equal to. Second option, upper limit an equal to. And the third option, lower limit an equal to. And the last option, upper limit an equal to. This is 2, this is 1, this is 1, this is minus 1. So this is the lower limit of n, and this is correct, A, option A correct, and this is also the upper limit, this is B. A and B are correct, but this is here lower limit, so option C not correct and option D is also not correct. So A and B are the correct option. Given that limit n tends to infinity, an equal to A, and limit n tends to infinity, bn equal to B, and sequence Sn and sequence Tn are two sequences such that Sn equal to maximum of an bn and Tn equal to minimum of an bn. Then option A, Sn is convergent. Option B, sequence Tn is convergent. Option C, limit n tends to infinity, Sn equal to maximum of AB, and option D, limit n tends to infinity, Tn equal to minimum of AB. Equal to maximum of ANBN and Tn equal to minimum of ANBN. So we can write this equal to half an minus bn plus mod of an minus bn. Right? This is half an minus bn plus half an plus bn Here Sn equal to maximum of n bn. This is equal to half n plus bn plus n mod of n minus bn. Also, this is equal to half an plus bn minus mod of an minus bn. Okay. Since limit n tends to infinity, an equal to a, and limit n tends to infinity, bn equal to b. So we can write limit n tends to infinity Sn equal to half into a plus b plus mod of a minus b, right? And limit n tends to infinity Tn equal to half a plus b minus a minus b mod. Okay. Now from these two conditions we clearly say that both the limit Sn and limit Tn are exist. That is we say that the limits, the given sequence are convergent. So first option A, sequence Sn convergent. Option B, sequence Tn convergent. Also this can be written as max of AB, and this also can be written as mean of AB. And the option C is sequence limit n tends to infinity Sn equal to max of AB. This is also correct. And the last option D, limit n tends to infinity Tn is minimum of AB. This is also correct. So the option A, option B, option C and option D, 4 are correct. The series summation 3, 6 to dot to 3n by 7 into 10 into 13 to dot 3n plus 4 into x to the power n, where x greater than 0 is option A, convergence if x greater than 1, diverges if x less equal to 1, converges if x less equal to 1, and option D, diverges if x greater than 1. From the series we can write the general term un equal to this and un plus 1 is equal to this. Now we test the series by D'Alembert ratio test. Un plus 1 by un is equal to 3, 6, 9 to 3n into 3n plus 3 by 7, 10 to 3n plus 4 into 3n plus 7 into x to the power n plus 1, and here also 7, 10 to 3n plus 4 by 3, 6 to 3n into 1 by x to the power n. That is, we get here only left 3n plus 3 and here this, and all the other terms are cancelled, and here only x remains. That is 3n plus 3 by 3n plus 7 into x, right? So 3 plus 3 by n by 3 plus 7 by n into x, and this is tends to x. And from D'Alembert ratio test we say that if x less than 1 then convergent, if x greater than 1 then divergent, but if x equal to 1 then test fail. Now we use Rabi's test for convergence. This test gives n into un by un plus 1 minus 1. Here x is 1, that is only left this part. And since un by un plus 1, so we get n into 3n plus 7 by 3n plus 3 minus 1. That is n into 4 by 3n plus 3, right? 3n plus 3 here, so 7 minus 3, 4, and this is equal to 4 by 3 plus 3 by n. This is tends to 4 by 3. 4 by 3, that is greater than 1. So by Rabi's test, if L greater than 1, then the series is convergent. So we say that by Rabi's test, in this case, if x equal to 1, then series convergent. So from here and here we get if x less equal to 1 is convergent and if x greater than 1 is divergent. So here the option C, that is convergent if x less equal to 1, and option D, that is divergent if x greater than 1, are correct. So the option C and D are correct. Which of the following is or are correct? Option A, summation un is convergent series, imply summation un by 1 plus un is also convergent series. Option B, summation un square is convergent, imply summation un by n is convergent. Option C, summation un is convergent, imply summation un square is convergent. And the last option is option D, none of the above. And this is the last question of the class. In option A, summation un is convergent, imply summation un by 1 plus un is convergent. We have un by 1 plus un always less equal to un, right? So by comparison test, if summation un is convergent, then summation un by 1 plus un is convergent. Okay, so this is right. Option B, summation un square is convergent, imply summation un by n is convergent. Here we choose the inequality un minus un by n, 1 minus n whole square. This is obviously greater equal to 0. Now we get un square plus 1 by n square greater equal to 2 un by n, that is un by n less equal to half into un square plus 1 by n square. If we take this is equal to k and un square plus 1 by n square less equal to un by n. We know that from the given condition summation un square is convergent. Also summation 1 by n square is convergent because this is p series with p equal to 2. P series with p equal to 2. Right? So un square plus 1 by n square is convergent. So by comparison test, this series summation un square by n, summation un by n left hand side series must be convergent, right? So this is also correct. And the last option, option C, summation un is convergent. So from the definition of convergent series, we say that if summation un is convergent, then un must be tends to 0 as n tends to infinity, right? That is the definition of convergence. We get there exists A belongs to capital N for any pre-assigned epsilon greater than 0 such that mod of un minus 0 less than epsilon for all n greater or equal to k. That is un less than epsilon imply un square less than epsilon into un. Here summation un square less than epsilon into summation un. Clearly, if this series is convergent, so by comparison test this series must be convergent. Okay, so the option C is also correct. So none of them, option D is not correct. So here option A, B and option C are correct. Okay, this is today's class. Okay, thank you for watching.